say that the first thing I want to do is I want to discuss what each of these are in degrees. So what is pi over 3 in degrees? If pi is the same thing as 180 degrees, what's pi divided by 3 in degrees? 60. Pi over 4 is what? 45. That's 180 degrees split into 4 parts. Pi over 6, what is it? 30 degrees. And pi over 2, 90. These are the 4 critical radian, really, denominators that we have to get used to. A denominator of 3, 4, 6, and 2. And I showed this yesterday, but on this first example, we are splitting pi into 3 parts. Now, this is pi, correct? Pi is a half circle. So if I'm going to split this into thirds, kind of ignore the y-axis, that would be 1 pi over 3, or just pi over 3. Here would be 2 pi over 3, and this would be 3 pi over 3, aka pi. So does everyone see the 3 parts? Here's the first part, here's the second section, and here's the third section. I have split pi into thirds. So 1 pi over 3, 2 pi over 3, 3 pi over 3. And then on my way around the rest of the circle, I'm also going to split it into thirds. And guess what? The first third is going to be the opposite ray to this one. So it's going to go just backwards. How would I label that if I continue counting? 4 pi over 3. Then this one extended is going to be 5 pi over 3. And then this one is going to be 6 pi over 3. Which, when you reduce that, is obviously the same thing as 2 pi. And hopefully by now we know 2 pi is a full circle. Yes? Okay. Pi over 4. We're going to split this half circle of pi into 4 parts. Now this one's going to be a little bit cleaner because we actually aren't going to ignore the y-axis. We're going to use it. Because here's 1 pi over 4. This is what? 2 pi over 4? AKA, what does that reduce to? Pi over 2. Or 1/2 pi, yeah. Then we're going to have 3 pi over 4. And then we're going to have 4 pi over 4. AKA pi. So do you see the 4 parts I just separated that into? There's 1, there's 2, there's 3. We'll call them wedges. I'm not going to call them pie pieces because that's confusing, because then there's the pie number and then there's the pie that you eat. So we'll call them wedges. So you see the 4 wedges that this got cut into. Then we have, what's this? 5 pi over 4. What's this? 6 pi over 4, but this one reduces, aka 3 pi over 2. Very good. And then, so 6 pi over 4, 7 pi over 4, and coincidentally or not, 8 pi over 4, which coincides with 2 pi. Nice? Okay, we'll do the same thing with pi over 6. Now, splitting it up into 6 parts. So this half circle is going to get split up into 6 parts. So each quadrant is getting split up into what? 3. So we'll do that. We'll do that. So this will be 1 pi over 6. What's this one? 2 pi over 6, which aka is what? Pi over 3, which let's just point out for a second that that location of 2 pi over 6 is the exact location, it should be, this isn't drawn perfectly, as this pi over 3. Yes? Pi over 3 and 2 pi over 6 are the same angle. And then this is 3 pi over 6, aka, what does that reduce to again and again and again? Pi over 2. And then we have 4 pi over 6, 5 pi over 6, and 6 pi over 6. And actually 4 pi over 6 coincides with what other angle? Which is actually the same angle, just a reduced version of it. 4/6. Reduce 4/6. 2/3. Good. Andrew, thank you. So the 2 pi over 3 is always going to trump the 4 pi over 6. We're not going to talk about 4 pi over 6 very often because it's going to reduce into a 2 pi over 3 angle, and we always use the reduced version. Same thing with 3 pi over 6. We're not going to talk about that often. It'll be the pi over 2 that we talk about. But at any rate, this was cut into 6 wedges. Each of those wedges is 1 pi over 6 radians, which we said was how many degrees? At the top of the paper, pi over 6 was how many degrees? 30. Can you confirm that 30 degrees plus 30 degrees plus 30 degrees plus 30 degrees 6 times is going to be 180 degrees? Okay? And then if we were going on the bottom, we would have 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and ta-da, 12 pi over 6. A lot of those reduce. 7 pi over 6 does not reduce, but 8 pi over 6 will, 9 pi over 6 will, 10 pi over 6 will, 11 pi over 6 will not. And then, of course, 12 pi over 6, aka 2 pi. I'm trying not to use slash because I don't want this, slash to be confused with the slash from 12 pi over 6. Okay? And then there's pi over 2, which really splits this pi, this half circle, into just 2 parts. And the y-axis is already doing that. So this is 0, this is 1 pi over 2, and this guy is 2 pi over 2. This guy is 3 pi over 2, and this one is 4 pi over 2 slash 2 pi. And we already talked about pi over 2 is 180 degrees. Or I'm sorry, 90 degrees, which obviously makes sense. You all know this angle is 90 pretty easily. Okay? So that's kind of the counting process of locating where a certain angle is. And we're going to do a whole bunch of this on the back, and we're going to search for the reference angle. And I'm going to talk about this the same way I talked about it yesterday. Look at your denominator. That's the first thing that you do, because that's going to dictate how I want you to label pi. Okay? If your denominator is 4, label that 4 pi over 4. That'll get you to your half circle. And then what would your full circle label be? 8 pi over 4. So if you think about, a clock, these being different little ticks. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, and 8. You don't really have to go around the whole way to get to 7 pi over 4. You just know that that's 1 tick prior to 8, correct? Does that make sense to you guys? 7 pi over 4 is 1 tick prior to 8 pi over 4. So your initial ray is always where it is. Your rotation diagram, if I get rid of these little arrows, is opening in the positive direction to 7 pi over 4, which is right there. Now, the second part of the instructions up top to plotting is to what's the reference angle? What is the angle between 7 pi over 4 and the x-axis? Right, set from 7 pi over 4 to 8 pi over 4 is 1 pi over 4. So your reference equals pi over 4. Okie doke. Okay, 3 pi over 2. How am I going to label this? denominator is 2, so how should I label this? 2 pi over 2. So if you kind of go through your counting, here's 0, here's 1 pi over 2, here's 2 pi over 2, here's 3 pi over 2. So your initial ray is where it always is. Then we go around, and this is 3 pi over 2. What's the reference angle here? Okay, Andrew just said 90 degrees. You're not wrong, but I'm going to talk about this more at the end. If the angle is given to you in radians, then you need to present the reference angle also in radians. You're not going to go back and forth, okay? So if this is 3 pi over 2 and this one is 2 pi over 2, what's the reference angle? Pi over 2. And honestly, you could go to this x-axis as well here, 3 pi over 2 versus 4 pi over 2. Here it doesn't matter because you're right in the middle. So it's just pi over 2. Okay? In C, Evan, how should I label this? Based on the way the angle's presented. I'll give you a hint. What's the denominator of my angle? 3. So now do you know how to label this? Raise your hand if you can help him. Oh. Negative or 3 pi over 3. Yeah, but you're right, because we're going the negative direction. What I was looking for is 3 pi over 3. So whatever the denominator is, kind of label it that way. And yes, because we're going negative, let's do that. So if we have negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, we're opening this direction, right? Negative 4 pi over 3 is going to be one tick past that. Yes? So initial ray. Evan, does that make sense to you? The labeling of that? So I'll come to you on the next one. So this being negative 4 pi over 3, what is my reference angle, do you think, John? Very good, yeah, pi over 3. Negative 3 pi over 3 to negative 4 pi over 3 is just pi over 3. Any questions? Yeah. Reference angles are always positive. So if it's degrees, they're between 0 and 90. I shouldn't put x, I should put ref, so you know what I'm talking about. Reference angles in degrees, always between 0 and 90. In radians, always between 0 and pi over 2. So they always are positive, unless it's 0, obviously. 0 is not positive or negative. Okay? If it's in radians but in decimal, that's between 0 and 1.57. Okie doke? Alright, so Evan, on this one, how do I label this x-axis over here? 6 pi over 6, very good. And on this one, we are opening in the positive direction. So 6 pi over 6 to 7 pi over 6 is just one tick past 6 pi over 6. So that's 7 pi over 6. And what's the reference angle? Kaylee, M. Good. Now, have you noticed anything about your reference angles? I don't need to read that. I do love every moment.
Isn't this some sort of like worshipping a false god thing? It's Valentine's thing.
It is.
Yeah.
I'm all about fake gods.
Well, girls love Valentine's Day. They get stuff. Guys just get hurt.
Oh, that's true. That is true. Deal with it. All right. What did you say? Who said something? Who noticed something about the reference angle? Maggie? bad example. Could you look at this one and tell me what the reference angle is? Who said that? Good, pi over 2. Maggie, could you look at this one and tell me what the reference angle is? Very good. Could you look at this one and tell me what the reference angle is? Very good. So, Bo said it. It's always 1 pi over the denominator. That is true in most cases. There are a couple exceptions. E being one of them, of course. Okay. The reason this is an exception is because this can be simplified. What does this simplify to? Negative 2 pi. So we're opening in the negative direction, and negative 2 pi is just a full circle. So this is an exception because, number one, it's not really splitting it into any parts. So your initial right and your terminal right are on top of each other. So what's the measure of that reference angle? 0. That's the only exception on this paper. And that's because it can be simplified. So I'm going to jump down to the bottom and show you the only other exception. Does anybody have something written at the bottom between I, J, and K? Somebody does. Who does? Does anybody have an example under I, J, and K that's like handwritten in there?
I thought this through earlier, and
How about I give you 5 pi over 7. So, example, we're going to still do this, we'll do the same thing. We're going to plot each of the following and find the reference angle. So, I, J, K, L, M. Let's do it for 5 pi over 7. This one's not going to be pi over 7. Nate? But you can divide 360 by 10, and the same, something similar would happen if I did a 10. It's a good guess. It's not exactly why. I'll tell you in a minute. But how should I label this, Connor? Okay, so what quadrant is 5 pi over 7 going to fall in? The second, right? Because what's this? That's halfway there. So that's 3.5 pi over 7. So 5 pi over 7 somehow is in here. So what's the reference angle? What is the difference between 5 pi over 7 and 7 pi over 7? 2 pi over 7, right? From 5 pi over 7 to 7 pi over 7 is 2 pi over 7. Now, I'll be honest with you. You're not going to have to worry about this very often because 7 is not one of our special denominators. Okay? And yeah, I guess in a certain way, Nate, you are right. If 180 doesn't divide by it evenly, it's definitely out. But there are other examples that 180 does divide evenly by that are out as well. But really, these are the cases you're going to come across the most, and you'll see why over the next several weeks. We're not going to deal with a denominator of 7 very often because it's not one of our specials. Do you remember why these are special degrees by any chance? No? Yeah, we're going to do that. But 30s, 45s, 60s, 90s, those are all special right triangle angles. And I don't know how much time you spent on special right triangles. I'm going to go a different way here. I'm still going to stay radians, but I'm going to give you 5. If there's no degree symbol, we know it's radians. So 5 radians. I'm switching gears because every example on the back here was in terms of 5, or was in terms of pi radians. This is just 5. So our labels are different. We talked about this the other day. 1.57, 3.14. What was this one? 4.71. If you needed a calculator, you could just keep adding 1.57, and then this one is 6.28. So where does 5 fall? Which quadrant? Just in case people don't remember the quadrants, it's 1, 2, 3, 4. I don't want to take that for granted, but yes, it's between 4.71 and 6.28, so it's right here. We opened up this direction, so our reference is 1.28. And then lastly, I'm going to go back to degrees for a minute. Let's do, I don't know, 200 degrees. So when we are in degrees, we label in degrees. 0, 90, 180, 270, 360. What quadrant are we in, Isaiah? Third. And our reference angle, Lydia? / Kirsten. What? 20. Yep, between here and here. Reference is 20. So there are 3 different kind of worlds out there where we can do the same thing in all worlds. Radians in terms of pi, which is kind of done with one thought process. Radians in terms of decimals, done with another thought process. Radians in terms of degrees. Here is back to the point that I was making with you earlier. If it starts with radians in terms of pi, keep your reference angle in radians in terms of pi. If it starts with an angle with radians just as a number, keep your reference angle as just radians as a number. And if it's in degrees, keep your reference angle in degrees. Stay in the world that the problem originates in. Yes, there's kind of 3 different planets here. So what time are we out of here? Oh, well. You're right, 26. Oh, well timed. Okay, so you have a worksheet. It's kind of a review sheet for homework. It's really all